Welcome back to Disruptors Unleashed, the series that explores the disruptive technologies shaping our world and the trailblazers igniting change across industries. In our previous episode, we discussed how disassembly can help achieve circularity with Tim McAloon from the Technical University of Denmark. Now, we look at inventory, specifically how big data, 3D printing, and automation can be harnessed to minimize inventory, maximize throughput, and revolutionize inventory management. Our guests are Melanie Anthony and Mike Bradford from Dassault Systems.
Hello and welcome to our conversations on manufacturing topics and trends. The future is lean, agile, and digital. With me today is Mike Bradford, Delmire's Strategic Business Development Director. Hello, Mike, and thank you for joining us today.
Hi, Melanie. Thank you for having me.
All right, so let's begin. Could you give us your view on the use of technology in inventory management?
Sure. There's really a lot of good technology available, things like RFID, robots and automated guided vehicles, or AGVs, automated storage and retrieval systems, cobots, which are cooperative robots that can work in proximity with human beings and recognize their presence to ensure there's no injuries, smart bins to help with the picking process to ensure operators are getting the right parts out of bins at line side, and several others. The problem is these are severely underutilized. There's also a lot of new technology, which is really interesting and exciting. Things like smart glasses being used not just for work instructions in the plant, but being used in the warehouse to guide picking and put away. Things like drones inside the warehouse. Something called RPA, or robotic process automation. It's not a robot, it's actually AI software that tracks what operators do, and for repetitive tasks, it can actually automate those repetitive tasks. And then video analytics, which is a capability to automatically analyze video, detect or determine temporal and spatial or time and space type events. But before you can use these advanced tools, you need to have the basics.
That's a great overview, Mike. So my next question would be, what are the critical gaps in inventory management and how can digital transformation help address them?
So I really see three key critical gaps. The first one is lack of automation. We already talked about the fact that it's very underutilized. McKinsey did a study that showed only about 20% of warehouses are effectively using automation. That's a very low number considering how many years some of this automation has been available. And this lack of automation has a very high cost. A 2018 study said that a typical warehouse with 100 non-supervisor employees costs about $3.7 million a year in labor expenses. And those costs are even higher now due to the post-COVID labor shortage. So there's a big cost there. The second gap that I see is a lack of integrated, consolidated, real-time data due to multiple data silos and multiple systems. This starts at design, where a weak link between design and actual material flow or material volume exists, so that it's hard to plan effectively for plant layout and material handling. There's also typically a limited or very little link between your demand and supply planning, to your production planning, to your logistics planning, to your execution, without feedback from execution. So that chain typically is broken in one or more places. And then there's little or no integration between warehouse and production. This is critical. This is key for minimizing inventories and maximizing throughput on your shop floor. The reason this happens is typically an ERP system or a warehouse system has limited visibility into what's really happening on the shop floor. They know what's gone into an assembly process and what's come out, but anything in between is a black hole. So the only time they're aware of actual inventory is when an item leaves the assembly line. Then they know all the components for that item have been consumed. But in reality, they're consumed different items at different steps in the assembly line. So that lack of visibility between warehouse and production causes shortages at the line. It causes too much inventory at the line to avoid those shortages. So there are a lot of issues with that lack of integration between warehouse and MBS. And then the third gap is IIoT and 3D printing. They're still looked at as manufacturing apps, which they are, but they can also have great application or at least great effect in the warehouse and in terms of inventory management.
You mentioned automation, data visibility, and 3D printing. So how can manufacturers make use of these capabilities? Can you give us some examples?
Sure. I'll take each of these three separately. So first, full data visibility. Full data visibility really requires consolidated data from multiple different sources, but it's key to many benefits in warehouse and inventory management. Ideally, full data visibility starts with virtual models, a virtual twin of the warehouse to ensure the right layout and the right material flow in the warehouse. So when you're building or configuring the warehouse, that digital twin can give you a picture not only of size and space and storage space, but also material flow. We've got a customer right now who has, in their manufacturing facility, they have about 100 AGVs, automated guided vehicles. And they have a spot in their plant that they call Spaghetti Junction because almost all of those AGVs have to go through this one spot. And it becomes a traffic jam. The AGVs actually have to stop and wait for other AGVs to go through. If you have a digital twin of your, not just the facility, but the material flows, the AGV flows, if you can do a virtual twin up front, you can alleviate that sort of situation by providing other places, other paths for your AGVs to go. So that's it starts there with a virtual model. Then back to the supply and demand planning. It requires data from a lot of different areas. It requires data from ERP to create valid plans. It actually even starts before that. It requires forecasting data, which can be manual or calculated by a system. It requires customer orders from ERP to create those plans. Then production plan needs that data plus warehouse and inventory data, how much we have, where it is, and so forth, which typically comes from ERP or warehouse management. Actual production data, which comes from MES, and purchasing plans, which comes again from ERP. All this data needs to be available in sync together in order to generate and maintain effective plans. So it implies not only all this data together, but feedback between execution in production and in the warehouse back to the planning systems. And effective execution in the warehouse requires planning data, but also real-time production data to meet the needs of your internal customers, your production people, while still minimizing inventories. Back to that situation of the black hole. If you've got effective integration, effective visibility, full data visibility between your warehouse and your MES, then you can synchronize materials to the line in real time. An example of that, we have a customer that builds combines. Every combine on their line is unique. What they are able to do with full data visibility is when a combine hits station 2, that triggers a picking event to their warehouse management people to pick a kit specific to that combine for station 7, because they know based on tack time, that gives the warehouse person enough time to go and pick those parts and deliver them to the line. Without that level of visibility from station to station to station, you're not able to do that. Then performance data, part of that full data visibility, we need performance data in real time or near real time. It's critical to ongoing effectiveness improvements. It enables identification of bottlenecks, slow-moving inventory, storage space issues, and so forth. And then continuity of all this data can provide the basis for predictive analytics to help more effectively manage warehouse space, manage material movement paths, and to identify storage issues, supply issues, material handling issues before they even occur. Next, let's talk robotics. And when I'm talking about robotics, I'm including automated guided vehicles, cobots, which we talked about earlier. They're collaborative robots that can work with humans, and traditional robotic equipment. Those together can provide significant improvements in several areas. Number one, in speed. Studies have been done, and a human order picker can do about 60 to 80 picks per hour. If you add robots, sorters, conveyors, Now you can do 300 picks per hour. So you're getting a 3 to 5 time improvement in your picking speed. Another improvement through robotics is safety. By automating the handling of heavy, bulky, and or awkward items with robots or cobots, you can reduce back injuries, you can reduce crush or pinch injuries, you can reduce forklift collisions, and so forth. That's important. Safety is a key measure for most companies, for most production companies. In 2016, a study was done that showed that 5 workplace injuries occur for every 100 workers each year. So 5% of your workers experience injuries in a year. So if we can use robots and automation to reduce that, that's valuable in terms of your safety. And then finally, cost. As we mentioned earlier, labor costs are high and going higher. In fact, it's estimated that labor costs constitute 65% of warehouse operating budget. That's a huge number. So and again, the post-COVID labor issues are going to make that go even higher. Finally, 3D printing. Raw materials for 3D printing require minimal storage. So on-demand 3D printing can enable make-to-order for manufacturers so that you can reduce on-hand finished goods inventories, which are your most expensive, and also reduce material handling, because now you can take production directly from the production area to the dock rather than taking it from production, putting it in a warehouse, letting it sit there, and taking it to the dock. This also enables you to move production closer to your intended market because it requires much less equipment than traditional manufacturing, so you can shorten your supply chain. 3D printing can also reduce or even eliminate storage space required for spare parts. Because spare parts orders are lower in volume and typically have less stringent delivery date requirements than production parts, they're a perfect candidate to be 3D printed and immediately shipped on demand. Once again, significantly reducing your warehouse space requirements and your material handling requirements. MIT research suggests that adopting 3D printing for those types of parts can reduce spare parts inventory by 90%, yet still ensure 100% availability.
Those are some remarkable examples, Mike. Thank you so much for that. Which leads nicely into my next question. What are the barriers for manufacturers who want to implement these capabilities and shift to a fully digital approach?
So I see several barriers. The biggest single barrier that I see is those siloed systems and data that I talked about earlier. The lack of integration between systems has a huge impact on the ability to implement effective digital technologies and inventory control. You can do pieces, you can do parts, but to do a true, fully digital warehouse, you need to knock down those silos. This is where a broad platform-based solution that crosses multiple functional silos can be a significant enabler for companies seeking a fully digital approach to inventory management. Another barrier is operational inflexibility. Many companies don't have the flexibility in their current systems and processes to take full advantage of these capabilities. I've heard some systems compared to cement. When you bring in cement, it's pliable, right? You can put it into any shape that you want. Once it sets, you can't change it. Unfortunately, a lot of software systems are like that as well. Once they're set up, it's very difficult to change them. You need flexible systems in order to take advantage of that, but those inflexible systems are a significant gap. And then finally, too many companies focus too much on cost versus value. They're looking at the cost of these capabilities without really evaluating and understand the potential value. That's where something like a value engagement, where you have people come in and look at your costs and where and how you can improve, is valuable, because that focus, when you focus too much on cost, you lose the visibility of what the value is, both short-term and long-term, and how much something like this is worth and how much it can help.
Speaking of value, how can digital inventory management help manufacturers be future-ready?
So future success in manufacturing requires resiliency. And you hear a lot of analysts and consultants talking about that. Well, it requires resiliency in design, production, quality, and materials and inventory across your entire supply chain. Digital inventory management is a key component of that resiliency. It provides the ability to minimize inventories and costs in the short term and in the long term. visualize and analyze changes and impacts in real time, so you know what needs to change, what has changed, and what the impact is. It enables adjustments to variations in the supply, demand, and production process. It enables you to react to market and industry changes, which is more of a long-term view, long-term change. And it enables you to reduce future issues and crises through predictive analytics. These abilities can help a company be truly future ready.
Well, Mike, that was the last question I had for you today. Thank you very much for your insights on reshaping inventory management.
You're very welcome.
Disruptors Unleashed is produced by Dassault Systems. For more episodes, follow us on Apple Podcasts, Spotify, Deezer, or your nearest audio streaming platform. To learn more about Dassault Systems, visit us at 3ds.com.